We're live. Hello, boys. Okay, these are the practice problems for 2.1, page 49 through 50, evens. Your homework will be the odds, and just like last time, I'll be going through these kind of quickly because I know y'all can go back and pause and rewind if you need to. I'm just here to I like to walk y'all through the thinking process that I go through when I solve problems like this. And then when you actually apply them, you can do the odds. You can apply those same thinking strategies. So, for problems 1 through 6, the assignment, the instructions are: determine whether the number in parentheses is a solution to the equation. And remember, a solution means that if you plug in that value and simplify, you'll get the same thing on each side of the equal sign. And we'll see an example of that being true and that being false. But if you don't recall, just go back to the 2.1 lesson. But we're going to test to see if these problems are a solution. So we do that through substitution. So first thing we do, we're testing the number in parentheses. The question is this a solution? So 4 minus, we're substituting, replace that m with a 7, equals 3. 4 minus 7 equals negative 3 equals 3. Is negative 3 equal to 3? No. Therefore, it is not a solution. Number 4, 50 equals b plus 10. The question is 60 a solution? Let's find out. 50 equals, first thing we do is substitute, replace that b with a 60. It's usually good to keep it in parentheses. 60 plus 10 is 70. Does 50 equal to 70? No. Therefore, 60 is not a solution. Oh, I'm missing. Which asks, so the question we can ask is, which value for b would be a solution? Which value of b would make this true? Well, if we replace b with 40, 40 plus 10 is 50. 40 would be a solution, but 60 is not. And we'll see the same thing with 6. 2c plus 3 equals 16. Is 10 a solution? Replace that c with a 10. Plus 3 equals 13. What do we do first? PEMDAS, no parentheses, well, technically parentheses. Exponents, multiplication, division, those parentheses act as multiplication. 2 times 10 is 20. Rewrite everything we didn't use. 20 plus 3 is 23. Is 23 equal to 13? No, therefore 10 is not a solution. What would have been a solution? Well, if we replace c with 5, 5 times 2 is 10, 10 plus 3 is 13. But 10 is not a solution. For problems 7 through 22. Hello. Excuse that. Today I'm in the market, so I may be interrupted from time to time. Okay, so like I said, 7 through 22, just good old-fashioned algebra. So let's just knock these out. Let's get started. All right. And remember, I'm going to go through these thinking processes. I want y'all to do a very similar thinking process when you go through these problems. So first, we rewrite it. X plus 7 equals 10. And our goal is to get the variable by itself. What is happening to x? X is being added to x plus 7. What's the opposite of adding? What is the opposite of adding by 7 / how do we undo addition by 7? We subtract by 7. So subtract by 7, what we do to one side, we got to do to the other. These things cancel. What are we left with on the left? X. 10 minus 7 gives us 3. X equals 3. All right, x minus 3.5 equals 8. What's happening to x? Subtracted by 3.5. What's the opposite? How do we undo subtraction by 3.5? We add 3.5. What we do to one side, we got to do to the other. These things cancel. What are we left with? X. 8 plus 3.5 gives us 11.5. Done. What's happening to x down here in 12? Or z. Z plus 2/3 equals 6 and a 1/6. Sorry for all the interruptions. I can't remember what my sentence was, so I'm going to just have to start fresh each time. Z plus 2/3 equals 6 over 6 and a 1/6. What's the, how do we undo? Addition by 2/3, subtract by 2/3. 2/3 minus 2/3. These things cancel. We're left with z on the left. What about the right? Well, we can't subtract. What's our rule for subtracting by fractions? They have to have the same denominator. So we can do that, but we also want to, it's going to be easier if we convert 6 and a 1/6 from a mixed number into a improper fraction. So we do that. 6 times 6 is 36, plus 1 gives us 37 over 6, minus 2/3. That doesn't solve our problem quite yet. We still got to get the same denominator. What's the least common least common multiple of 6 and 3, it's going to be 6. So all we got to do in this case, how do we turn a 3 into a 6? We multiply by 2. So let's multiply by 2. What we do to one side, we got to do to the other. So negative 2 times 2 gives us negative 4. 3 times 2 gives us 6. So now we have 37 over 6 minus 4 over 6, which gives us gives us 33 over 6. Remember, two negatives make a positive only applies in multiplication. Right here we're just subtracting. And then to finish it off, we can convert this. We can keep it like this, but it's usually better, or it's not usually better. Sometimes it just looks better if we convert it back into a mixed number. 6 goes into 33 5 times with a remainder of 3 over 6, and 3 over 6 is the same as 1/2. So 5 and half. Yeah, okay, great. Oh, I already have 14 on the page. Okay. X plus 3/4 equals 7. How do we undo addition by 3/4? We subtract 3/4. What we do to one side, we got to do to the other. These cancel, we're left with x. And now we have the same problem. We can't subtract unless they have the same denominator. First thing we want to do is turn 7 into a fraction. We turn it blue again. 7 over 1 minus 3 over 4. And we're looking at the denominators. We have 4 and 1. What's the least common multiple between 4 and 1? Well, it's 4. We multiply this by 4 over 4. That gives us 28 over 4. This stays the same. Minus 3 over 4 gives us 25 over 4. We can leave it like that, or like I said, we can convert it. How many times do you actually, normally, almost always, I'm going to want you to keep it in the improper fraction. But for the sake of seeing the other side, we'll convert it. So how many times does 4 go into 24? 6 times with a remainder of 1/4. But I would prefer this answer. And back at 12, we can do that. But the other thing we can do in this case is we can simplify. What factor do 33 and 6 have in common? They're both divisible by 3. Divide by 3 gives us 2. Divide by 3 gives us 11. So this is the same as 11 over 2, which is also the same as 5 over 12. But for the sake of your answers, I'd like to see you keep them in improper fractions. You can convert them here if you want, but I prefer this. We're just continuing doing the same thing. Start with 16. 2 plus x equals 7. What's happening to x? It's a little different because x is on the other side, but we can still see that it's 2 plus x, and if we use our commutative property, that's the same as x plus 2. So we can subtract. What's the opposite? How do we undo addition by 2? We subtract by 2. What we do to one side, we got to do to the other. These cancel. We're left with x on this side. 7 minus 2 is 5. That's our solution. X minus 6 is 10. What's happening to x? Minus 6. How do we undo subtraction by 6? We add by 6. What we do to one side, we got to do to the other. These cancel. We're left with x. 10 plus 6 equals 16. That's the solution. X plus 0.06 equals 5.25. How do we undo addition by 0.06? We subtract by 0.06. What we do to one side, we got to do to the other. These cancel. We're left with h. 5.25 minus 6. We can do it the long way. 15 minus 6 gives us the 9. 1 minus 0 gives us the 1. Then we got 5. H equals 5.19. That's the solution. All right, 17 over 14 equals k plus 5 over 7. How do we undo addition by 5 over 7? We subtract by 5 over 7. What we do to one side, we got to do to the other. Just erase that because we're going to need that room. These cancel, we're left with k. And then we got 17 over 14 minus 5 over 7. We can't add or subtract fractions unless they have the same denominator. What's the least common denominator between 14 and 7? 14. 14 is already 14, so we just got to multiply by what to turn 7 into 14? 2 over 2, which is going to give us negative 10 over 14. So now we have 17 over 14 minus 10 over 14. I know this is a little messy, but I hope you can follow along. That gives us 7 over 14 equals k. These are still the same piece. This is technically a right answer, but remember we can reduce. They both have a 7 in common. 7 divided by 7 is 1. 14 divided by 7 is 2. So 1/2 equals k would be the actual correct solution. for questions 1 through 4, we're turning our English sentences into math sentences. 2 less than a number. So whenever we see a number, we know that we have a variable, so let's go ahead and write that variable. And now 2 less than a number. So even though it's written first in English, this less than is what we're thinking about. So let's use an example that we can do easily. Let's replace this number with something we already know. So let's say 2 less than 3. Is 2 less than 3? What is 2 less than 3? 2 less than 3 is 1. So how do we set up that problem? We would set it up 3 minus 2 equals 1. So this tells us that a number would come first, and then 2 less than would be the second thing in that phrase. So for this case, 2 less than a number, we do x minus 2. So when we don't know exactly the wording, replace the number we don't know with a number you know how to work with and see what you come up with, and that can usually help you find the right solution. 10 decreased by twice a number. So we know, so let's always start with our variable. Let's make that a habit. Twice a number. So we have a number, twice a number. What are we going to do to make that twice a number? Just give it a coefficient of 2. 10 decreased by twice a number. So let's just say 10 decreased by 3. What's 10 decreased by 3? 7. So how do we set up that problem? 10 decreased by 3 equals 7. So that shows us that 10 goes first, and whatever we're decreasing by comes second. So we can have the same setup right here. 10 decreased by twice a number. There we go. So these word problems, if you're stuck, plug it in with numbers you know how to work with. Can't remember if I've said it because it's been so long since I unpaused, but 5 through 16 are just simplification problems, so we'll go through. So number 6, PEMDAS, parentheses no, exponents yes. So let's take a look. Very important, remember, this negative doesn't apply unless it's inside parentheses. So in this case, we're just looking at 3 squared. So 3 multiplied by itself twice, 3 times 3 gives us 9. We'll rewrite everything that we haven't touched. All right, next, parentheses no, exponents no, multiplication, division no, addition, subtraction yes. We'll do it left to right. 6 minus 9 is negative 3. Negative 3 plus 6 is 3. 3 minus 7, negative 4. Okay, to the right we have negative outside of brackets, negative 2 times negative 3, bracket. Parentheses, yes, let's go to the innermost parentheses. Technically this one, but that's not, it's already simplified on the inside, so we'll go to the next parentheses. What's going on in here? We got multiplication. We got negative 2 times negative 3. Two negatives make a positive, so we got 2 times 3, 6. 2 negatives make a positive, just means we have positive 6. So rewrite everything we didn't touch. That gives us positive 6. And then we have negative 6, which just gives us negative 6. Negative 3 times negative 1/2 plus 5 times negative 4 times 2. Parentheses, yes, but technically not because everything inside the parentheses is already simplified. When we say parentheses, we're talking about inside the parentheses. So there's nothing to do inside parentheses here. Exponents, no. Multiplication, division, yes. Negative 3 times negative 1/2. We can treat this as 3 over 1. 3 over 1 times 1 over 2. 3 times 1 is 3. 1 times 2 is 2. So we got 3 over 2, and then we got 2 negatives. That's not a negative sign, that was just a tap. 2 negatives make a positive, which means we're just working with 3 over 2. Over here we got 5, positive 5 times negative 4 times 2. Let's start with 5 times 2 gives us 10. 10 times negative 4 gives us negative 40. And remember, that stays negative. Even though it's a plus, this gets factored into this whole multiplication here. So because we have an odd number of negative signs, the whole thing becomes negative. Then we have 3 over 2 equals 40. We can only subtract if we have the same denominator. Let's go ahead and make that a fraction. How do we turn 4 over 1 to have a denominator of 2? 3 over 2, we multiply this by 2 over 2, which will give us 80 over 2. And then we got 3 minus 80, which gives us negative 77 over 2. Super weird. That's all we can do. We can leave it in its fractional state. Yeah, that's the answer. That's weird. All right. And then we have negative 3.261 plus 5.423. Instead of trying to figure out how we work with this negative number, let's just use the commutative property and flip it around. So let's move this positive number up front. 5.423, and remember with the commutative property, the signs are going to follow along with the thing that follows it. And then we'll move that second, negative 3.261, and this is a subtraction problem we know how to work with. Let's write it up and down like we normally do, or like we can. We don't have to if we don't need to, but that gives us 2, cancel, blah, blah, 6. 3 minus 2 is 1, 2.162. Alright, and then we got 14 and 16. We'll do that on the next page. And I'm back. That just felt like a short moment for you, but for me, maybe it's been half an hour. I don't know. Point is, I don't remember where we were, so I'll just start at question 14. Negative 3 over 4 times 2 over 9 plus 3 over 8 times negative 1.5, or 1/2. So first thing we want to do, parentheses, yes, but everything's done inside of that. Exponents, no, and I'm going to have to pause again. Okay, first thing in order of operations that we can do is multiplication and division. So let's start with, I'm on the wrong screen. Let's start with the first one we see. So multiplying by fractions, we can just multiply straight across, but let's do some factor canceling. What do we have in common on the top and the bottom? Well, 2 and 4 both have 2 in common. 2 divided by 2 is 1. 4 divided by 2 is 2. 3 and 9 both have 3 in common. 3 divided by 3 is 1. 9 divided by 3 is 3. So we're left with negative 1 times 1 over 2 times 3. Negative 1 times 1 is negative 1. 2 times 3 is 6. And then over here, 3 over 8 times negative 1 over 2. We can't do any canceling. 3 times 1 is 3. 8 times 2 is 16. And then we got a negative times a positive, which means it's negative. So we got 3 over 16. And now we can, in order to add or subtract fractions, they have to have the same denominator. What's the least common multiple between 16 and 6? Ooh, this is an ugly one. Hold on. 48. So we get negative 1 over 6. We got to change this to 48. We can do that by multiplying by something. What do we multiply by? 8. Which gives us negative 8 over 48. Negative 3 over 16. Multiply by 3 over 3 to get 48. Negative 3 times 3 is negative 9. So now we have negative 8 over 48 minus negative 9 over 48, which gives us negative 17 over 48. Let me double check that. Yep. Alright. And then lastly, 3 times, what do these bars mean? That's the absolute value sign. 6 times the absolute value of negative 3 plus negative 8. So first thing we can do, we can kind of treat that absolute value as parentheses. Whatever absolute value just turns whatever's inside positive. So we got 6 times 3 plus negative 8. PEMDAS, parentheses, yeah, but these don't count because everything inside is already simplified. Exponents, multiplication, division. We got 6 times 3 is 18. Rewrite everything we didn't touch. And then what do? When the two sides are touching, we can treat this like distribution even. Treat it like a positive 1. Positive 1 times negative 8 gives us negative 8. So then we got 18 minus 8. 18 minus 8 is 10. Alright, now it's whatever. That's page 49 through 50 evens for example. If you have any questions, let me know. Okay, bye.